Welcome to this lecture. In this lecture, we will be finding out the price of European call option using the formula that we derived from the Black Scholes equation. So let us just revisit the formula. It will help us to frame the Python code. So this is the formula for an European value of European call option, same as that of European put option, and then we have D1 and D2. Now if you observe, we have around 5 parameters involved. S is the stock price, K is the strike price, R is the risk-free rate of return, T is the time to maturity, and then we have sigma, which is the volatility of the stock. Now you might wonder what is ND1. So it is nothing but the cumulative distribution function of a random variable D1 which follows a normal distribution. So let us start the Python implementation of this formula. So it is pretty much simple and intuitive as well. So let us first import numpy because we are dealing with a lot of mathematical functions, for example square root, log and all. So import numpy as np, and then from scipy.stats we will be importing norm. It will help us CDF, right? So from scipy.stats import norm. Okay. Uh, so far so good. We will be defining the function Black Scholes, which will give us the call price if we give us the parameter like S, K, T, risk-free rate R, and sigma, right? So now let us start by defining D1. So if we see D1 over here, D1 is ln of S0 by K plus R plus sigma square by 2 into T, right? So this one is np.log S by K, right, plus T into R plus sigma square, right? This will be sigma square divided by 2, and then this one is capital T, right? And then whole term, so we have written the numerator term, so numerator divided by, we have denominator is sigma root T, right? So it is pretty much simple. So it is sigma into np dot square root of T, right? So yeah, we have written the numerator term, d1 term basically, and now d2 term is pretty much simple. d2 is d1 minus sigma root T, right? So it will be sigma into square root of T, right? So np square root of T gives us the root, right? And then we are pretty much done. So we just have to return the price of call option, and if you see the price of call option, it will be S0 into so this will be the stock price into ND1 minus K to the power minus RT into ND2. So it is pretty much simple. So we will be writing S0 S into, so S0 is basically S and into ND1, right? So we can get the ND1 as norm.cdf into d1 with mean of 0 and variance of 1, minus, we know the formula, k into exponential of so the exponential function can be given from here, minus r into t, right, and multiplied by norm.cdf of d2, as simple as that. And so this function gives us nothing but the Black Scholes formula, right? So if we revisit the equation, so it is basically r plus sigma square by 2 into t. So this one is r plus sigma square by 2 into t, and then we this whole term is the numerator over here, right? And then we are dividing it by sigma into square root of t, right? And this term is the second term of the numerator, right? So T into R plus sigma square by 2. So we just need to give some parameter and find the call price. So it is as simple as that. So call price is equal to, give the parameter Black Scholes. Let us just give the parameter. So basically S, let us have S as 100, a strike price K is 110, maturity period is 3 months, so basically 0.25 years. The risk free rate R is basically, let us have it as 7%, so 0.07. Volatility, so let us volatility be 12%, okay, so 0.12. And now if you find call price, so it would give you the required call price. So you get the call price as 0.28, right? So yeah, and that is how we do it, as simple as that.